Solving exponential equations. In the first example, 7 to the x equals 7 to the third, we notice that the bases are the same, and so we can set the exponents equal. X equals 3, which is the solution to my equation. To test that solution, I'll substitute 3 in place of x in my original equation, and I get a true statement. In the next example, let's rewrite 16 as a power of 2 to the fourth power. Now we'll set our exponents equal and solve for x. We'll test this solution for x by substituting it into the original equation. We're saying 2 raised to the opposite of -4 power equals 16. 2 to the fourth does equal 16. So my solution of x equals -4 is correct. In the next equation, we'll remember to write 4 as a power of 2. We'll set our exponents equal and solve for x. To test that 3/2 is the correct solution, we'll substitute it in place of x in the original equation. 2 times 3/2 is 3. And 2 to the 3 minus 1 is the same thing as saying 2 to the second power, which does equal 4. So my equation has a correct solution of x equals 3/2. We'll solve 2 more examples. 27 can be written as 3 to the third power. Now let's apply the power of a power rule. 3 times 2/2 is 6/2. We'll set our exponents equal. This is a quadratic equation. We can solve it by subtracting 6x from both sides and factoring that trinomial. Now we'll apply the zero product property and we get 2 solutions, x equals 7 or x equals -1. On the equation on the right-hand side, we can write everything in terms of 2 to a certain power. And so 4 can be written as 2 squared raised to the x times 2 to the x squared is equal to 2 to the fourth squared. Now we'll apply our power of a power rule. And now because we have the same base and we're multiplying, we can add our exponents on the left. And here again, we have a quadratic equation which we can solve by factoring this trinomial. We'll get 2 solutions. Here we have an example. E to the x equals e to the 3x plus 8. Once again, setting our exponents equal, we'll solve for x. We get that x is equal to -4. We can test this value by substituting -4 in place of x in our original equation. And we get a true statement that e to the -4 equals e to the -4. So my solution of x equals -4 is correct. One last example. If 4 to the x equals 7, what does 4 to the -2x equal? So when I look at 4 to the -2x, I can take the given information of 4 to the x, and I can represent 4 to the -2x as 4 to the x quantity to the -2 power. Now let's substitute what 4 to the x equals. So we'll say 7 to the -2 power. 7 to the -2 is 1 over 7 squared, or 1 over 49. So the answer to this problem is 1 over 49.